Hello everybody, I am a student of mechanical engineering and today I am going to speak on the topic Introduction to Gyroscopic Torque and Numerical about it. It's related to our course Machine and Mechanism. I am from BTech second year. I am from School of Mechanical Engineering and my name is Om Nikam and we have been guided by our course faculty uh, Chandore sir, Mr. Ashwin Chandore sir. So let's move on to the presentation and discuss in detail about our topic, gyroscopic torque and numerical related to it. So let's move on, everybody, and be concentrated towards our topic. Let's move on. Introduction to gyroscopic torque. In short, a gyroscopic torque is a turning moment or torque that resists any change in the inclination of the axis of rotation of gyroscope or in a spinning object, causing it to change direction instead of uh, falling over. Here we can see gyroscopic torque, as we can see in the diagram, is a turning moment or torque that can change inclination of an axis it means so that in a spinning object it can be balanced or it should be safe from changing direction or falling over. Let's move to the next slide. Uh, as you can see over here, angular momentum uh, is in this direction due to the right hand thumb rule. Uh, right angular momentum, the foundation. We can say the angular momentum is the foundation for our gyroscopic motion. Uh, Here the formula for angular momentum is L is equals to IA omega. Here L means angular momentum, which is in the unit the kg meter square per second. I is moment of inertia and omega is angular velocity, and their units are similarly given over here. Key concepts from here we can take it that angular momentum represents resistance to rotational change, and the direction aligns with rotation axis following the right hand rule. Here, the direction for the angular momentum is taken from the right hand rule. We need to curl our hands in the direction of rotation, similar in the direction of rotation, and the thumb will give us the direction of angular momentum. As in this, as in this here over here, we can see that the this is rotating in anti-clockwise direction. So the means the axis is rotating in anti-clockwise direction. So the angular momentum is in the left direction, as we can see. Uh, so in short, is that angular momentum is necessary for finding or calculating gyroscopic motion or torque. Understanding torque. What actually torque means? Torque is the defined as a twisting force that causes rotation around an axis.
फाइल एलिमेंट से पण करू का
हा
तू काय करू म्या तुझी बनव तू भाऊ आधी
नाही नाही, हे झालं नाही एवढंच.
ऍक्टिव्हिटी जागी काय दिवस
नाही, वर घे आता. ऍक्टिव्हिटी काय लिहून वर घे फक्त. बॅक स्पेस दाबून वर घे.
याला बोल्ड करू
बोल्ड कर. लय काय लोड. As we have defined torque, as it is a twisting force. Torque is a twisting force uh, that causes rotation around an axis. It is determined from the angular momentum. Right hand thumb rule is also used here for determining angular momentum, and similarly afterwards gyroscopic torque is determined, or any torque. And torque formula is torque is equals to R into F. For R is radius and F is force. Vector quantity means torque is a vector quantity. The direction determines the axis of rotation. The direction of the torque is determines the axis of rotation. Uh, Similarly, as we can see here, guys, before it we need to one discuss point. Uh, once again, yes, gyroscopic precision. Precision is the change in orientation of rotational axis. Means we can say change in rotational uh, change in orientation of rotational axis can be said as precision. Cause for it it is caused by torque applied perpendicular to spin axis. uh, Torque applied to perpendicular to spin axis will give us the precision, means will cause the precision. Uh, in this way, the direction, precision direction is perpendicular to both torque and spin axis. With the torque in the direction and spin direction, precision is perpendicular to both of them, to the torque and the axis which is spinning, or the spin axis. Let's move on to next slide. Gyroscopic torque equation. Uh, in this, we can see the equation is torque is equals to I omega ohm. The torque is tau is represented by gyroscopic torque. I is represented by moment of inertia. Omega is spin rate, and ohm is precision rate, which is in radian per second, and all other units are similarly given over here. The equation quantifies the magnitude of gyroscopic torque based on spin rate and precision. We can see the equation is related directly proportional to the gyroscopic torque, spin rate, and precision. Gyroscopic stability, rotation, balance, and stability. Gyroscopic stability is necessary for rotation, balancing the similar thing in which gyroscopic torque is required. Similarly, we can see in aeroplanes and ships, the balance is only due to the gyroscopic torque acting over there, or gyroscopic motion over acting over there, or any gyroscope acting over there. It helps in balancing things, and it also helps in rotation. Stability. Stability is main reason for gyroscope. It helps in stabilizing the things, as we have discussed about ships and aeroplanes. They are stable and can change direction easily due to this gyroscopic force or the torque. Gyroscope stability is essential in many applications. It relies on the principle of angular momentum and torque. Let's take a simple numerical about this. Uh, Here, I this moment of inertia is given 0.05 kg meter square. Omega is given 100 radian per second, that is spin rate, and ohm means precision rate is given 0.1 radian per second. So let's calculate torque. Uh, Torque is formula is I omega ohm. After putting all the values, we get the answer 0.5 Newton meter, as you can see here. Let's move on to the next question. A ship's propeller weighing 500 kg has a radius of gyration 0.3 meter. Uh, at 3000 rpm, clockwise when viewed from the front. The ship is turning left with an angular velocity of 0.2 radian per second. The engine is mounted uh, such that its axis but is horizontal and along the length of ship determine the moment of inertia of the propeller, the gyroscopic torque, the direction. Similarly, we need to calculate the moment of inertia. Let's first out or find given data. This is all the given data. Mass of propeller AM is equal to 500 kg. Radius of gyration K is equal to 0.3 meter. Rotational speed N is equal to 3000 rpm. Precisional angular velocity is given. Ohm is equal to 0.2 radian per second. Let's move on to next slide. Uh, Now let's calculate moment of inertia. The We can see over here core calculating moment of inertia. Formula is I is equal to mk square. K we have found. We all know the value of mk. So 500 into 0.3 square. 500 into 0.3 square. So after calculating I, we get the answer 45 uh, kg meter square. Uh, After that, we need to convert rotational speed to angular velocity. The rotational speed for converting to angular velocity is omega is equals to 2 pi n by 60 is the common formula we know. 100 pi, and the answer is 314.16 radian per second.
वे मॅनेजमेंट टाईप टाकू हा
Hmm.
काय टाकू
Compute gyroscopic torque. We need to compute gyroscopic torque. The gyroscopic torque is given by the formula. Uh, we can see over here. And as we have discussed previously also, uh, that gyroscopic torque is nothing but torque is equals to I omega ohm. The torque is directly proportional. The gyroscopic torque is proportional to I omega ohm, as we have discussed earlier. Torque after putting all the values we have got from the previous slides, the answer comes to 827.43 Newton meter. This was one of the simple numerical as well. We know if we know formula, we can solve easily the question, any type of question coming related to gyroscopic torque. Uh, let's move on to the next question. Next question, not next slide or next information. Real world applications of gyroscopic torque is in motorcycle, gyro compass, or INS. Similarly, I said in INS, aircraft, missiles, and spacecraft, it is used for balancing and stability. Motorcycles also enhance stability and handling. Gyro compass used in ships and aircraft navigation. As I previously discussed about ships and airplanes and aircraft, it helps with stability and changing directions. Gyroscopic results are using camera and robotics to reduce and shake and ensure stability. This system finds widespread use in many things, such as I have told earlier. Summary and conclusion. From this information, we learned about the qubit torque result from angular momentum uh, and applied torque. Uh, Equation for torque is I omega ohm, helps to quantify this effect, and application span across navigation, stabilization, and control. Gyroscopic torque is a crucial in various systems. It impacts stabilization and control mechanism. Thank you for the presentation. Thank you for attending session. You must have got some point from it. I accept it. I wanna thank you for listening to me. See you. Bye. Thank you. Thank you. Thank you.